Hello world! Now, episode number 1 of Multidisciplinary Engineering, as I call it, is about this little box. It's not specially about the spider on the box or the eggs of other spiders on the box. No, it's about what is written here. It's a Metoran Funk 5000 from Gilgen. Gilgen is a Swiss manufacturer of door opening systems. That baby is probably about 20 years old, and it was the receiver of a door opener for our garage here, and it spent the last 20 years in a plastic box where it waited for inputs of people wanting to get in. Now, if nowadays you want to get the emitter for this receiver, it's impossible. It's too old technology, it's some analog stuff. So and if you want to get the emitter for the actual receiver, Gilgen will charge you about $100. If I say bucks in general, it means either euros, US dollars or Swiss francs, which are all about in the same order of magnitude. So $100 for each one getting in. I see it's a very good business model. As I say, I'm multidisciplinary, so I highly value good business models. In the meantime, I know there's always a better business model if you can do it for less. So the project of my last weekend was to replace that baby with an old Raspberry Pi I had lying around. Because of my EveryCook project, many of you may know, I was tinkering with Raspberry Pis since the first Raspberry Pi came out, and I have a few left of these first Raspberry Pis. Oh, don't even know where they are in here. Let me check. Oh, yeah, right. Let me show you. That's the one I have here. It's here on the back. It's here on the back of that old Dell monitor. Actually, it has a broken SD card slot, so we had to hack it a little bit to still have the contacts of the SD card working. So that's one of these kind of leftover Raspberry Pis I had, because I mean, now the number 3 is out. What should you do with them? Even trying to implement some decent piece of software on outdated hardware is kind of wasting your time. I mean, you could have so much more computing power for these $40 that costs Raspberry Pi 3. So I have these lying around. So I took one of these, and as you can see on this box, oh, it's upside down. It's rather simple. We have an input for 24 volts AC or DC. I had to see that it is AC, so I had to put a rectifier in to get it into DC, and after getting it to DC, I could add a little DC-DC converter to convert it down to 5 volts for my Raspberry Pi, and on the other end we just have a simple switch. That's what I mean about multidisciplinary engineering. I never had a look at door systems before. I had some experience with industrial control systems, and I had more experience when it comes to tinkering home automation and cooking stuff. But in the end, it's always the same. You have 2 wires and you have to shorten them. You have to make a contact in between. That's how you open up cars, as Hollywood has told us. You start cars once you open them. So it's not that hard, and I figured out in the end the hardest part was to set up the Wi-Fi access point on the Raspberry Pi, because I had the wrong USB Wi-Fi connector on it. But let's have a look where this baby is in now. So it all started with that little box up here. Now we are outside of the garage in the ramp that goes down, and I realized that in the corner of this little box there's the same logo than was on the receiver. So of course first I noticed this one, opened it up and got the receiver out. So that's the box that was installed by the guy who made the automatic door opening for our garage door. As you see, we have 4 plastic screws at the corners, completely normal, unsecure screws. So that's about the safety level they installed 20 years ago. You just have to open up the box, shorten 2 wires, and you're in. So that was a point that comforted me that I can't make it worse than that. So it doesn't matter how safe my Raspberry Pi setup is, it's not going to be more unsafe than this setup was before. That's the second box. There is a second box inside, so that's the driveway, how it goes up, so where I can come in every day when I come back from work. And that is the second box we have inside with the whole control system. Rather simple control system with a few relays. But I didn't even have to figure out how exactly this system works, because I didn't even have to figure out how this control system works, because once I had found this little receiver, I knew, okay, these are the 2 wires I have to shorten. And yeah, the second point was to find out what is the voltage I have on the 24. It was 24, but AC, so I needed a rectifier, a DC-DC converter. But that's rather easy stuff. And I used one of the old EveryCook boards from the first generation of EveryCook, where we had a power transistor to control the motor of EveryCook. No, way over-dimensioned power transistor to switch a little relay, but it does the job, so I could convert from the Raspberry Pi GPIOs. It could make a high voltage, high current output, which was strong enough to switch that relay, which I noticed I don't have a relay left in my box of different electronic parts, so I had to take it out of that old receiver, because that old radio receiver, of course, had a relay to switch that, so it was easy to locate that on the board, unsolder it, and add it into my little assembly. And now everything is in that box and it works perfectly. Let me show you. Take my smartphone out. Wi-Fi is off now. Have a look over there. Smartphone. Wi-Fi on. Wait a few seconds. And Sesame, open yourself. Or how was it called in Alibaba? And yeah, that's pretty comfortable. And the good thing, we have a few seconds of delay between the moment where I come into that range of the Wi-Fi until it really connects. So if I'm quickly passing by, the door won't open. If I'm coming in with my car and I stand and wait, the door opens always. It's not faster than taking out my key and turning the key. That's the old switch we used to open up. Since I have my home keys at the same key ring than my car keys, this meant to turn off my car, take the keys out, put them into the other keyhole, turn them around to get the door open, which was a bit uncomfortable for me. So it's all about comfort. if you do it quickly, you're probably faster with the key than with that Wi-Fi connection. But I did it because I can. So that was the first idea of multidisciplinary engineering, and more examples will follow in the next videos. Two other things I forgot to mention. One is completely irrelevant, but I just enjoy that we have sunshine, we have the birds singing, it's getting spring, it's getting warmer. And the second thing is, look down below, you'll find the useful links to stuff if you want to build it like that. Basically, it's how to trigger a script if someone connects to your Wi-Fi, how to set up a Wi-Fi access point on Linux, especially on a Raspberry Pi, and I'll also quickly Google for you a link how to switch a relay from a GPIO pin, because you should not connect a relay directly to the GPIO pin or you will fry it. So, subscribe, link, whatever. I hope to see you later.